Okay, this will be our second part of our notes in logarithmic equations. And for the first part, let's go through and review how to simplify and solve logarithmic equations. Now, we will be using our three properties we've discussed in class. So if I have a logarithm that is separated with addition, we can always condense that to be multiplication. And so I have log 25 times 4, which is going to be log 100. And again, since our base is not written, we are going to assume that it is 10, and log base 10 of 100 is 2. And we will do the same thing with our next example. Again, we have this divided up with addition, so we will condense this with multiplication. So we have log base 2 of 3 over 2 times 32 over 3. And so with multiplying fractions, we can cross cancel. So our 3's will cancel out, leaving 1's. And 2 will go into 32 16 times. So notice we end up with log base 2 of 16. And again, just a quick reminder, that means 2 to what power is 16. And so we see that my answer should be 4. Now moving on with our next example, number 39, our logarithms are separated with subtraction. And so that means we have to condense with division. So we will condense these. We have log base 2, and this is going to be 40 divided by 5. And so we have log base 2, 40 divided by 5 is 8. And 2 to what power is 8? 2 to the third. Again, number 40, same idea, same process. Again, we are subtracting, so let us condense. But now this time, notice we are base 5 of 100 over 4. And so that's going to be log base 5 of 25. And 5 to what power is 25? 5 to the second. Okay, with our next problem, notice that we have exponent of 35. So that exponent needs to be moved down to the front. And so that's going to be 35 times log base 10 of 10. And log base 10 of 10 is just 1. So 35 times 1 is 35. And for number 42, we do need to work with our square root. And we need to remember that if I have the square root of 2, that's the same thing as having 2 raised to the 1/2 power. And that is still raised to the 5th. And when I have an exponent raised to an exponent, I need to multiply those two exponents. So over to the side, keep in mind we're saying 1 over 2 times the whole number 5. We need to put that over 1. And notice that I get log base 2 of 2 to the 5/2. And again, we can move our 5/2 to the front. And we are going to have 5/2 times log base 2 of 2, and that's really going to be 5/2 times 1, which is 5/2. Now, if you remembered our shortcut that we talked about, then you can save yourself a little bit of time here because we know that's 2 to the first, and 5/2 over 1 is 5/2. And you're welcome to use that shortcut if you remember it. Okay, number 43, again, more of the same. It looks like we're going to have some pretty ginormous numbers here because we will be condensing all of that to multiplication. So we have log, and then we're going to have 50 times 4 times 5. And so when we put all of that together, my gracious, what a number. That's going to be 50 times 20, which is going to be log of 1,000. Good grief. And so this again, we have to keep in mind 10 to what power is 1,000. And here just count your zeros. There's 3 zeros. So this answer should be 3. So for 44, yes, I know we have a funky looking base, but don't discriminate. It's a logarithm too. Be nice to it. So we're going to have log base 1/3. And notice here we're subtracting, so this is going to look weird. We've got 4/3. And keep in mind you change it to dividing. 4/3 divided by 12. And back. And whatever younger grade it was, heck, I don't remember. You would do a keep, change, flip, and remember dividing by fractions, you multiply by the reciprocal. 4 cancels into 12, leaving 3. So let's see what we have here. Log base 1/3 of, and that's going to be 1/9 of 1/9. So 1/3 to what power gives me 1/9? 1/3 squared gives me 1/9. So my answer is 2. Okay, with these equations, we will be using the same idea as we did earlier when we were trying to find a final answer. It's just now they've given us the final answer and we have to go in and find, well, what is that x value that's going to make this true? So this is saying 5 raised to the 2nd power is equal to all of this in here. So let's say if we can write that equation. So we've got 2x plus 5 equals 5 to the 2nd power. So that really means 2x plus 5 is equal to 25. And so when we finish solving that equation, we would subtract 5 and then divide by 2. So that looks like my x value should be 10. Now keep in mind, it's not saying that the logarithm is equal to 10. The logarithm was originally equal to 2. It's saying that this x value would have to be 10 in order to make this a true statement. Okay, so following the same idea for this next problem, we are going to say 3 raised to the 4th power is equal to all of this stuff here. And so let's see, we have 4x minus 7 equals 3 to the 4th. So we have 4x minus 7, and 3 to the 4th power is 81. So I have 4x equals 88. And so it looks like x is going to have to be 22. Okay, for the next problem, notice now that I have x is down here as a base. So we're going to have x squared, or x raised to the 2nd power, equals all of this on the inside. So 2x plus 8. And now this is where we're going to have to set up a factoring problem, that family-friendly F word that nobody likes. And from here, remember we need 2 parentheses. And we're going to have x and x. And we need to look at the values that we can multiply that give me 8, subtract, and get a -2. So it looks like we're going to need a -4 and a +2. And again, let's check our numbers and see. +2 times -4. Yep, that's -8. And what is -4 plus 2? That is -2. So if we set each part equal to 0, notice we solve and we get x equals -2 or x equals 4. Now by definition, I cannot have a base of a -2, so we will throw that out. So that final answer should be 4. All right, so for this particular problem, again, same process. So we're going to say 4 raised to the 1/2 power equals x squared minus x plus 2. Now keep in mind, 4 to the 1/2 power, that means the square root of 4 equals x squared minus x plus 2. And the square root of 4 is 2, so I have 2 equals x squared minus x plus 2. Now I'm going to subtract the 2 over, and so notice that's just going to leave me with 0 on the other side. So I'm getting to where I can factor and solve for x. So I have 0 equals x squared minus x. You have a GCF of x, so I'm going to factor that out. So I have x minus 1. and setting each part equal to 0, I get x equals 0 or x equals 1. And again, by definition, we can't have our base. Well, now this isn't a base. Sorry, please excuse me. So now we can have both values equal to 0. In earlier form, we could not have our base. X was a base, and that base could not be 0. But here where our variable is, it's quite okay to have 0. Okay, another example. Here we would need to condense this together by multiplication. So we're going to have log, and notice the base isn't written, so it's going to be base 10, and 4 times x minus 1, and that is equal to 2. And now we're going to say this is base 10, and 10 raised to the second power is equal to 4 times x minus 1. So that's going to be 100 equals 4x minus 4. And so we need to add 4 over. So we have 4x equals 104. So x is going to be equal to 26. So there we've combined several different steps all into one equation. Right, for this one, it's going to be very similar to the previous example. We will be condensing that with division because I have subtraction here. So log base 6, and this is going to be 35x plus 6 all over x, and that's equal to 2. And again, with our process, we're going to say 6 raised to the second power equals 35x plus 6 all over x. Now, please don't try to cancel this x here and this x here. You cannot do that. The algebra police will come and beat you upside the head, so don't do that. What we do need to do is go ahead and square 6, so we have 36, and we should have some kind of equation we can set up and solve here. Since x is in the denominator, I will multiply that over. So 36x equals 35x plus 6, and if we move our 35 over to the other side, we see that x is 6. And now we're going to solve exponential equations where we cannot get the base to be the same. Now, earlier equations that we solved, we were able to take this other side and write it as 3 to some power, but we're not going to be able to do that with 12. So what we have to do is find the log of both sides. So it's just like adding or subtracting something to both sides, taking the square root of both sides. Here we're going to say we're going to do the log of both sides. So we're going to say log of 3 raised to the x equals log of 12. Now we will use our logarithm property that says we can move our exponent down to the front. And so I have x times log base 3 equals log 12. And then finally, solving for x, we would divide both sides by log 3 and divide this side by log 3. And so my final answer, and I had rather you just leave it in this exact form. There's no need to do the calculator portion here. You're going to have x equals, and it's going to be log 12 over log 3. And please don't think you can reduce 3 and 12 because you can't. This would be the simplified version other than typing your solution or your answer into the calculator. Okay, same process with number 56. Again, my exponent is where I have my variables, so I'm going to have to do the logarithm of both sides. So I'm going to have log of 3.4 raised to the x plus 4 equals log 29.6. And again, we're going to move this whole part, all of this exponent needs to come down to the front. So I have x plus 4 times log 3.4 equals log 29.6. And remember your order of operations, these two things are being multiplied, so I'm going to go ahead and divide by log 3.4. So I have x plus 4 equals log 29.6 over log 3.4. And then our last part we would need to subtract over 4. So we have our final answer to be x equals log 29.6 over log 4. And then all of that is going to be minus 4. So we're just going to put minus 4 out here to the side. And again, you are more than welcome to leave your answer just like this. For this example, we will have a lot of the same steps, but with this one, notice how the problem is set up. Our x is here, and notice this is 4,000 times what 1.06 raised to the x. So the first thing I would do with this problem to simplify it would be to divide both sides by 4,000. And let's see, I'm going to be left with 1.06 raised to the x power. And then over here, if we start knocking off zeros, notice we have 10 over 4, which does reduce to 5/2. So that's going to make it a little bit easier to work with. Now we can do the log of both sides. And so that's going to allow me to move my exponent down. So I have log 5/2 equals log 1.06 all raised to the x power. And again, I will be moving the x down to the front. So I have log 5/2 equals x times log 1.06 and divide both sides by log 1.06. So my final answer here would be log of 5/2 divided by log of 1.06. And yes, I had much rather you leave your answers just like this. Don't be typing it in the calculator. Okay, and again, our x values are up in the exponent, so we need to go ahead, and we can't divide or anything like we did the previous problem. So what we're going to do is go ahead and say log of both sides. So we have log of 3 raised to the x equals log of 12 raised to the x minus 2. And then, let's see, we can move our x out to the front. So x log 3 equals x minus 2. Move that entire exponent down. Log 12. And then it looks like we're going to have to do some distributive property over on the other side because of that x there. So we're going to have x log 3 equals x log 12 minus 2 log 12. And again, keep in mind your goal is to get your x's together on one side. And so it looks like we might have to subtract over that log. So I have x log 3 minus x log 12 equals negative 2 log 12. And now we can go through, and I'm going to change colors here to help us see. We do have a GCF here, and that's why we put our x's together. We're going to factor out that x. So I have log 3 minus log 12 equals negative 2 log 12. And now we have our x over here, so we're going to divide both sides by everything inside the parentheses there. So we're going to have, let me get everything adjusted here, x is going to be equal to, and we had negative 2 log 12 over, and then everything that we're dividing by. So we've got log 3 minus log 12. And that's going to be your final answer. That's it. Just leave it just like that, no matter how terrible it looks. Okay, with our last two, we have a different base we're going to have to use. With all the previous ones, it was quite okay to use base 10. But anytime you see e, instead of doing log of both sides, let's do the natural log of both sides. And again, remember, ln is just abbreviation. Again, Let's review that. ln of x is the same thing as log base e of x. They just shorten it to be ln of x. That's the only difference. And again, we talked about the property ln of e to the x. My answer is always that exponent right there, because we will move that down to the front. And x times ln of e equals ln of 10. And ln of e is always 1. So that's going to be x times 1, which is x, equals natural log of 10. So there's our final answer. Okay, for our next answer, or problem, sorry, getting ahead of myself. We can go ahead, because 2 is just 2 over here by itself, times e. So let's go ahead and divide both sides by 2. So I have e to the 2x minus 5 equals 12. And again, since we're dealing with e, we're going to have to do the natural log of both sides. But our process is still the same. Our properties are still the same. We just need to use natural log instead of log. And so here we are going to move our exponent out to the front, 2x minus 5 times natural log of e equals the natural log of 12. So we have 2x minus 5 equals natural log of 12, again because natural log of e is 1. And so finishing the problem, we're going to add 5 and divide by 2. So x is equal to the natural log of 12, and then plus 5 all over 2. And again, you cannot combine the natural log of 12 and 5, so just leave it like it is. And so here would be your final answer on that one.